Constraint equation. If we impose some condition on the system, then it is called constraint on the system. For example, in this that is a string, block, and pulley system, the length of the string remains constant. If string is inextensible, then length of the string will remain always constant, and this is the constraint on this system. So we can write length of a string is always constant, that is L equals to constant. Now using this constraint, different problems and different problems can be solved. For example, in this example, question is that find the relation between the acceleration of block 1 and 2 between velocities, and also we have to find the relation between velocities. Here we fix a reference line passing through the center of the pulley and consider that this at any instant of time, let x1 and x2 be the displacement of 1 and 2, that is this body is at x1 from this reference line and this body is at x2 from this reference line. This is fixed line. From fixed line, let length of the string be L, then x1 plus x2 plus L naught equals to L, because this distance from here to here is x1 and we have considered this distance as L naught because it is also constant, and from here to here this distance is x2, so this will be the length of the string and it will be remain constant. So x1 plus x2 plus L naught equal to L. Now differentiating with respect to time, we get d by dx1 by dt plus dx2 by dt, dl naught by dt, that is 0, equals to dl by dt equals to 0. So we get v1 plus v2 equals to 0. This gives v1 equals to minus v2. That is, both body move with same velocity but in different direction, in opposite direction. Thus, the velocities of block 1 and block 2 is same in magnitude but opposite in direction. Again, differentiating equation 1, we get dv1 by d2 plus dv2 by dt, dv2 by dt equals to 0. This gives a1 plus a2 equals to 0 or a1 equals to minus a2. Again, acceleration of both bodies are same but in opposite to each other. Now next situation. Find the relation between A1, A2 and A3 shown in the figure. Let any instant situation is as shown in the figure. This is the fixed line. Okay. And now this block has distance x1. That is, this is block 1. And this blocks 2. From this reference line, the block distance of block 2 is x2 or displacement. Then this distance will be x2 minus x4 if this is x4. If this is x4, then this distance will be x2 minus x4. And this distance will be if that is block 3, displacement from the fixed line is if x3, then this displacement will be x3 minus x4. Now we can write, now we have x1 plus x4 plus L naught equals to L1, length of first string, that is here. This is the first string. Then we can write x1 plus L naught plus x4 equal to L equal to L1 equal to length of first string, and Now for length of second string, this x2 minus x4, this length, plus L0 plus x3 minus x4 equals to L2, that is length of second string, or this implies x2 plus from this x2 plus x3, x2 plus x3 minus 2x4 plus L0 equal to L2. Now representing equation 1 twice, we get a1 plus a2, a1 plus a4 equals to 0, or that is a1 equals to minus a4. This is equation 2. Again differentiating equation 2 twice, we get a2 plus a3 minus 2a4 equals to 0, or this implies a2 plus a3 minus 2 into minus of a1 equals to 0, or a2 plus a3 plus 2a1 equals to 0. Equation 3. This is the required relation between a1, a2 and n3. Next, find the relation between a1 and a2 in the given figure. Points 1, 2 and 3 and 4 are movable. That is, this is movable, 2 is movable, 3 is also movable, the center of this pulley, and center of this pulley 4 is also, but this is fixed. So we have drawn a fixed line from here. Now let displacement from a fixed line be x1, x2, x3 and x4 of respective point and pulley. Then we get x1 plus x3 equals to L1. This is the x1 and plus x3, this is the x3 distance. So this plus this and this length will give the we are, because L0 is in everywhere constant, so we are not considering this L0. So x1 plus x3 will be L1. Similarly for this will be x1 minus x3 plus x4 minus x3 equals to L2, length of this string. And similarly here x1 minus x4 plus x2 minus x2 minus x4 will give this length, will be equal to L3. So equation 2 and 3. Now differentiating all equation, we get a1 plus a3 equal to 0. Again a1 minus a3 plus a4 minus a3 equal to 0. a1 plus a4 minus 2a3 equal to 0. Again a1 minus a4 plus a2 minus a4 equal to 0. 1 plus a2 minus 2a4 equal to 0. This is equation 3. Putting values of a3 from equation 1 into, we get a1 plus a4 minus 2 into minus of a1 equal to 0. This implies a1 plus a4 plus 2a1 equal to 0. 3a1 plus a4 equal to 0. This gives a4 equal to minus 3a1. Again putting this value of a4 into 3, we get a1 plus a2 minus 2 to minus of 3a1 equal to 0. a1 plus a2 plus 6a1 equal to 0. 7a1 plus a2 equal to 0. Or this implies a2 equal to minus 7a1. Answer. Thus we get all desired value. Again next problem. Find the relation between a1 and a2. This is the mass m1 and this is the mass m2. That is, we have to find the relation between acceleration of mass m1 and acceleration of mass m2. Again we can use the constant relation. We have considered, because this is fixed, so we have considered this as a reference line, and this distance is considered y2 and this distance is considered y1. So this distance will be y1. There is no need to calculate this because it is given y2. So we can write y2 plus y2 in this direction, because this is distance y2, then this will be also y2. Then y2 plus y2 plus y1, this distance, and plus length of consider this length is L naught and this is L naught, all considering both length as a L naught, so L naught plus equal to L. So differentiating twice, we will get 2a2 plus a1 equals to 0. Since L naught and L are constant, so from this we get that is, from this we get a1 equals to minus 2a2. In magnitude a1 equals to 2a2, and now if a2 equals to then a, then a1 equals to 2a. Now FBD of m1, here FBD of m1 is shown, so we can write m1g minus t equals to m1a, or m1g minus t equals to, because a1 we have considered 2a, so putting this value m1 into 2a, or m1g minus t equal to 2m1 into a, equation 5. Again FBD of m2, t dash minus m2g equal to m2 into a2, or t dash minus m2g equals to m2 into a, equation 6. Now FBD of pulley, t and t dash, so we can hence t dash equal to 2t, t dash will be equals to 2t. Hence 4 becomes, equation 6 becomes 2t minus m2 into g equals to m2 into a. Now from equation 5 into 2 plus 8 we get 2m1g minus 2t equals to 4m1 into a, 2t minus m2 into g equals to m2 into a. Solving this, and 2t will cancel, so we have 2m1g minus m2g equal to 4m1 plus m2 into a, and this will give a equals to 2m1 minus m2 divided by 4m1 plus m2 into g. Again from 5 we will get t equals to m1g minus 2m1 into a, m1g minus 2m1 into, putting the value of a, 2m1 minus m2 divided by 4m1 plus m2 into g. And solving this, finally we get the value of t as 2m1 square plus 3m1 into m2 divided by 4m1 plus m2 into g whole g. If we solve from 8, we get t equal to m2 into g plus a by 2, m2 into m2 by 2 into g plus 2m1 minus m2 divided by 4m1 plus m2 into g, or g m2 by 2, 4m1 plus m2 into 2m1 minus m2, because g has taken out of bracket, divided by 4m1 plus m2. Now m2 m2 will cancel out, so g into m2 by 2 equals to 4m1 plus 2m1 equal to 6m1 divided by 4m1 plus m2, or we get t equal to 3m1 into m2 divided by 4m1 plus m2 under bracket into g.